Good afternoon. She'd had such terrible experiences evacuating in the past, and that's how we ended up evacuating in the middle of the night after the contraflow got set up over the bridge crossing over Lake Pontchartrain. But as a sociologist, I remember looking back at the city in the middle of the night and thinking. With this storm on the way and with the social realities as they are in New Orleans, and with the very uneven distribution of vulnerability and resources in New Orleans that exists, this is a foreseeable situation where thousands of people could lose their lives, and it did end up being a catastrophe of exactly that magnitude. And sociologists in the years since Katrina have devoted quite a lot of attention to the Katrina diaspora and the experience of people as they try to recover from the storm. And a lot of the scholarship of Katrina underscores what I would say is the fundamental truth of the field of sociology of disasters, which is that there's really no such thing as a natural disaster. Disasters are fundamentally social in their context. You can see a screenshot here from a really nice video from the Natural Hazards Center at the University of Colorado in Boulder, where they discuss 70 years of social science disaster research, and how it points to the ways in which the lived consequences of environmental hazards and natural hazards are a function of the built environment. What you're going to hear about from the transportation professionals here today, as well as the social structure and the economic context. What do we know that's relevant and hopefully helpful about the social structure and economic context that distribute the effects of natural hazards in the ways that they combine with the built environment? Well, the number one thing is that, across very many disasters, across, decades of disasters research, a finding that is robustly replicated is that people tend to respond in overwhelmingly pro-social ways. The kinds of panics and rioting and looting and things like that many popular depictions focus on are just not that true. People tend to be overwhelmingly pro-social. In being pro-social, they're drawing on their existing social networks, their existing social organizations, and their existing habits of running their everyday lives. And so one of the ways to understand how disasters will affect people, especially as they relate to the transportation system, is to look at how people in the organizations that they live in, so their workplaces, their families, their community organizations, how do those relate to the transportation infrastructure? Where are things located, for instance? What kinds of transportation resources do people draw on, as they go about their daily mobility lives? Another insight from this literature that's helpful in this context is that transportation is yet another one among many of the very unevenly distributed resilience resources. And so the social differentiation of transportation resources and the social differentiation in how people engage in different forms of mobility, how they use different modes of transportation, tends to be a very helpful avenue of research for understanding resilience and adaptation to disasters. And then the last point I would make here is that sociology tends to be very focused on inequality and distributions and equity and inequity and variation. And the field has identified several different dimensions of this unevenly distributed resilience resource of transportation. And you can put them into four different categories. First category, probably relatively familiar to folks, race, class, gender, age, family, as things that differentiate the populations that use transportation systems. Also, spatial unevenness, spatial factors of proximity, of density, are things that drive the uneven distribution of transportation resources. Capacity is another axis of variation here. People in different social situations have different abilities to substitute, one resource for another in a disaster context, and obviously the specifics of that are going to depend on, which exact transportation system you're looking at. But then there's a procedural element here too, which I'll conclude with, and that is, for those of us that are doing, forward-looking work on making transportation systems more resilient and more adaptive to the kinds of stressors that we'll see from, climate-driven water, climate-driven heat, other climate and non-climate driven disasters. I think it's helpful to relate to the public in a way that is oriented towards solving common problems. Oftentimes, if you're interested in finding out what the most important disaster resources and limitations and vulnerabilities are, people who live with those transportation systems every day often have a lot of insight in how those work on a day-to-day basis. And there are very many different approaches to public engagement and community engagement. And based on what the literature on that has found, I would advocate strongly for approaching members of the public as partners in solving actual problems. And I can say more about that in the discussion. But let me turn it over now to our panelists. Let me get out of my screen share. And I'm going to turn it over to Sarah and Angela from the Port Authority of New York and New Jersey.
Thank you, Jason. Thank you for the opportunity to present. My name is Angela Wong. I'm a senior climate resiliency specialist, and today I will be presenting with my colleague Sarah Colasurdo, program manager of climate resilience, and we both sit within the Resilient and Sustainable Engineering unit within the Port Authority of New York and New Jersey. The Port Authority is vital for keeping the New York and New Jersey region moving, and our authority oversees the various facilities in the categories of air, land, rail, and sea. Within our aviation portfolio, we have a number of very important international airports. For our portfolio, within our portfolio of tunnels, bridges, and terminals, we oversee some of the busiest tunnels and bridges in the world. And within our port facility, we make sure we're leveraging our historic harbor to bring in goods from all over the world. We also run the Port Authority Trans-Hudson system, which is the urban transit system between New York City and northern New Jersey. And the historic World Trade Center is an important transportation hub that's also part of the Port Authority Trans-Hudson system. In 2012, the New York City region was devastated by Superstorm Sandy, but over the past 10 plus years, we find ourselves much more prepared and a lot more resilient, and with lessons learned to share with all of you today. Since Hurricane Sandy, the Port Authority has embarked on an aggressive physical risk mitigation program, and we'll detail those actions over the course of this presentation. But in summary, some of the actions that we've taken over the past decade plus include installing 80 rapid flood control measures within 1 year of Hurricane Sandy. We've also spent $2.7 billion on Sandy recovery and storm hardening projects. And for all projects within our capital plan, we've instilled much stronger design standards in current and future floodplains, which take into account sea level rise. But in addition to coastal flooding, we've also had a major new focus on mitigating risks from intense precipitation as well as extreme heat. And to help with that, we've recently completed a proactive climate risk assessment that addresses all of those three hazards: coastal flooding, intense precipitation, and extreme heat, with a focus on critical assets across all of our facilities. And as a key output of the climate risk assessment, we've developed a 10-year resilience capital plan that will hopefully provide for additional resilience investments throughout all of our facilities. On the next few slides, we'll provide some snapshots of the physical risk mitigation interventions that we've undertaken across all of our facilities after Hurricane Sandy to protect against coastal flooding. This is at LaGuardia Airport, where we elevated a substation to account for sea level rise. And across all of our aviation facilities, we've implemented measures such as replacing the airfield lighting systems. We've also protected pumps and substations and other critical equipment, as well as improved drainage. And all of this helps our aviation facilities get back up and running after a storm passes and it's safe to fly again. When Superstorm Sandy hit, the World Trade Center was a giant construction pit, which allowed for a lot of coastal flooding to flood in. But we've incorporated flood resiliency into the design of the World Trade Center campus, and now it features a 3-tiered flood protection system, which starts with the bollard protection system, which is shown here. It leverages the security bollards as the structural supports for deployable flood planks as the first barrier for protection. And then we have second ring, which includes at-grade protections at all the building entrances and vent shafts. And then finally, we have subgrade protections for critical equipment, as well as a high-capacity pumping station. And this flood resilience program was built for the 100-year storm, which plus 3 feet of sea level rise, which takes into account the useful life of the facility. Within our bridges and tunnels portfolio, the Holland Tunnel was one of the few facilities that was vulnerable to flooding, and that included flooding of the tunnels, including through the ventilation buildings, which served as a flood entry pathway. And so in this project that's featured here on the slide, we designed deployable flood log barriers at the ventilation buildings to mitigate that flood pathway. And this is designed to withstand the 100-year storm surge event plus 3 feet of sea level rise, which again takes into account the useful life of the asset. And then the PATH system, the urban transit rail system, was one of the most vulnerable facilities and systems within our Port Authority portfolio, partially because the majority of the system is underground. So that led to a lot of flooding throughout the PATH system. Since then, we've rebuilt the damaged tunnel infrastructure. We've protected all the vulnerable station head houses, entrances, and also elevated or hardened a lot of the substations and signal communication systems throughout the PATH system. And in this example, we protected an elevator that served as a major flood pathway. We did that by including watertight stainless steel, as well as an aquarium glass head house. And this was also designed to withstand the 100-year storm plus 3 feet of sea level rise. And then lastly, for our ports portfolio, we've also focused on flood-proofing critical port assets, such as the pump house and substation. And this helps us make sure that we're able to continue to move goods after a storm passes. And nearly a decade after Hurricane Sandy, the New York and New Jersey region was also hit with a new type of emerging hazard for our region. We we um, we were faced with Hurricane Ida, which brought significant heavy rainfall, and within the peak hour, the 1 hour rainfall intensity was 3.58 inches per hour. This was unprecedented and is equivalent to a 500-year storm event. Even though we received an unprecedented rainfall, our facility did not experience material business impacts, although we did experience some operational impacts at the facilities, and despite the limited physical impacts, we still embarked on implementing post-event mitigations, including preventative maintenance, operational enhancements, and engineered solutions. Some examples included cleaning out catch basins and sealing leaks to prevent flooding from future high-intensity rainfall events. We also added in generators and deployable flood control devices, as well as made operational changes such as pre-planning detours around intersections that are prone to flood. And we also reviewed the Port Authority capital plan to make sure we're identifying potential resilience improvements. And then in terms of the third hazard that we are concerned about, extreme heat is a chronic hazard that can have impacts on assets, customers, and employees. Given that we're within the engineering department, we're well aware of the extreme heat impacts on assets, including critical electrical systems, mechanical systems, and materials, which can affect our civil infrastructure. But in addition, we are preparing for extreme heat impacts on humans, especially given that there could be increased likelihood of heat disorders with increases in temperature and relative humidity. And so being proactive in addressing extreme heat requires a different set of tools from our toolbox, such as communications with customers and employees. So we're really making sure that we're taking a holistic approach to climate resilience within our transportation systems. And now I'll turn it over to my colleague to talk about our overall climate resilience program.
Great. Thank you, Angela. Yeah, so I'm going to transition now to our climate resilience program, like Angela was saying. The resilience program is led by the engineering department, but it has substantial coordination across the entire agency for an all-of-government approach to climate resilience. It consists of our resilience action plan, the climate risk assessment, and our climate resilience design guidelines. The longest standing aspect of the resilience program is the climate resilience guidelines, which require a higher standard for new construction. And then our climate risk assessment has been our opportunity to take a step back, look out over the entire landscape of Port Authority facilities that evaluate our critical assets against current and future climate risks. The climate risk assessment complements the design guidelines by identifying unmet needs that we wouldn't necessarily have encountered if we were just addressing climate risk in our new construction projects. So we use the climate risk assessment to recommend resilience projects to our business line departments to improve their resiliency. And finally, the resilience action plan is a multi-pronged approach to implementing resilience across the agency, from communications to risk management, and it has the furthest reach to influencing a culture of resilience throughout the agency. Briefly digging into our climate resilience guidelines, they are required and they're prescriptive. The application of them is essentially considered to be the default unless a project team can show that the risk is sufficiently low or the scope is too limited. And where we apply it, the guidelines require that a project be protected to a design flood elevation that's adjusted with sea level rise commensurate with the service life of the asset, just like Angela was showing you for some of those prior post-Sandy projects. So the guidelines only address sea level rise and storm surge to date, and there are a few reasons for that. There are existing building code standards for flood protection, and it's relatively simple to adjust them to account for rising sea levels. Setting higher standards for intense rainfall and heat based on available projections is trickier. And second, after Sandy, we were kind of myopic about storm surge. We, um, you know, San like Angela said, it was almost 10 years later, Hurricane Ida was a wake-up call to the hazard of intense rainfall. So we're quite overdue for an update to our design guidelines, but we are kicking off a guideline update actually as we speak. So we're looking to be able to share that in early 2026 with primarily with heat and rainfall. So in action, our climate resilience guidelines are applied to, like I said, new construction, also major redevelopments like our airports of EWR, LaGuardia, and JFK. So in this case, ground floors are either elevated or flood-proofed to the sea level rise adjusted design flood elevation. And within and around the new terminals and new infrastructure, all critical assets are elevated above the design flood elevation. And then that second prong of our climate resilience program, the climate risk assessment, we're wrapping it up this year. It's a very granular engineering driven analysis to proactively uncover and mitigate risks. There are a few really key items that I want to highlight. To keep the study manageable, we paid particular attention to assets that contribute meaningfully to key operations with KPIs relating to Port Authority variable revenue or regional economic benefit. We took a systems approach. We looked at how assets contribute to systems and in turn how those systems support essential functions of our facilities so that we could understand the cost of inaction. And it also helped to demonstrate what is at stake and help to guide our mitigation priorities and budgets. Third, we designed the methodology with the explicit goal of resulting in projects. We needed to combine the asset and systems approach so we could pinpoint the weakest links in the chains, and the critical assets with the highest failure probabilities and consequences were considered for mitigation. And then finally, we were mindful of the business processes that we wanted the mitigation projects to feed into. So we designed the project scope deliverables to mirror capital planning process and grant application deliverables. We also collected data in a format that would align with our enterprise asset management system so we could integrate the data back into the asset systems and not preclude data from being used by anyone in the agency with unique asset identifiers. And by the numbers, we evaluated 17 facilities, collected data on nearly 7,000 critical assets, and recommended over 100 mitigation measures to our line departments. When we presented the recommendation to the departments in spring 2025, they've been incorporated into the capital plan considerations, and we're hoping for the 26 to 2035 capital plan that there will be a carve out for resilience-driven projects. And finally, the Resilience Action Plan. It's kind of a catch-all for additional strategies to expand the reach of resilience and sustainable design to the agency and outside the agency. The climate impacts will touch every aspect of our business and operations, so we wanted to get ahead of it to establish robust and coordinated planning. So through a process of benchmarking and gap analysis, we determined that we could be most effective at building a coordinated culture of resilience if we improved in these 7 areas. One of them that I wanted to highlight was staying abreast of emerging technologies. So we were able to engage a consultant who conducted a scan of over 40 different technologies in the areas of asset design and monitoring, disaster management, hazard monitoring, operational support software, strategic climate planning, and worker health monitoring. And one way in which we're fulfilling the goals of the RAP for communications is to share more openly with the public about our climate resilience efforts. So the design guidelines have long been public. You can find them on our website. We'll we could put the link in the chat, and also the link to our public website where we've shared the research and methodology for the climate risk assessment. We spent nearly 2 years designing the methodology and the standard operating procedures and developing the supporting tools. So we didn't want that investment to stop with us, particularly because there are many organizations that don't have the funding or the bandwidth or the leadership to support devoting 2 years to this. So we hope others will use these resources and improve upon them and advance the whole field of climate risk assessment. And of course, this is all in support of an ongoing resilience cycle of implementation and monitoring and reevaluation, and occasionally interrupted by a climate event, which gives new data into our resilience cycle. At a minimum, we envision that this cycle will repeat for the Port Authority on a 10-year basis, which aligns with our 10-year capital planning process. And then in reality, there are little cyclonic movements that happen all along the way that we try to harness to advance our cause. And just wrapping up some of the key takeaways that were on our minds when we were preparing for this presentation, as we were thinking back on 10 years of implementing our guidelines and 4 years of carrying out the climate risk assessment. We'd like to share that try to scope studies that will directly inform decision-making, pair incremental improvements in adaptive design with long-term strategic planning, design for multi-hazard resilience, seeking solutions that will address multiple climate risks, ensure operational ease, keeping end users in mind during design, plan for timely replacement at the end of mitigation measures life cycles, prioritize assets that support transportation essential functions, and nurture a culture of resilience that spans all of your business processes. And I'll just say thank you for letting us share our experiences with your community and helping to broaden our collective culture of resilience.
Thank you so much, Angela and Sarah. That was absolutely wonderful. Please do send the URL for the CRA tools to Beverly, and then I think Beverly has the ability to send them back out to all the participants. That would be absolutely fantastic. Thank you. I know that we've got some questions in the chat for the smaller clarification ones. Again, to the panelists, feel free to answer those if you want, and I'll also be collecting questions for broader discussion, and I'll moderate a conversation at the end of the webinar. But right now, I would like to turn it over to Curran Mohney with the Oregon Department of Transportation, who's going to tell us about the Unstable Slopes program.
Thank you, Jason. I'm very happy to be here today. I'd like to talk to you, well, first introduce myself, Curran Mohney. I'm with the Oregon Department of Transportation. I'm the engineering geology program lead, and as part of that job, I manage the Unstable Slopes program that I'll speak about in more detail. So even though I'm a state DOT person and talking about highways primarily, the problems that we have with landslides on highways also apply to every other form of linear transportation asset, be it railroad, waterways, pipelines, or utility corridors. All are affected similarly to the disruptions caused by landslides. So we have a bit of a problem with landslides in Oregon in that we have too many of them. And as part of my work with the Unstable Slopes program, we keep a physical inventory of landslides that affect the state's highways. And there are a lot of them. And so we use a risk-based scoring system to rank and prioritize sites for further attention. Landslides are very expensive to repair. Landslide repair projects have a very high environmental impact. And so also on a limited budget, we have to be very selective about which ones we're going to allocate funding to. And I think this map shows the problem better than the numbers do. So we have our risk-based system, and naturally the hotter and bigger the dot, the worse that problem location is based on certain risk criteria. And you can't see the highway underneath the dots in a lot of areas. But, as part of our inventory work, we've now counted up well over 4,000 landslides on the state's highways. And, that totals up to about 495 miles of highway affected, or about 7% of the system. And 7% might not sound like a big number, but that's more of a percent than you really want to have actively moving or having something drop on you at any time. And if we attached all the landslides end to end, that's enough length to go across the state and almost all the way down the state. So it is a big problem, and the numbers are working against us on it. And so why do we have so many landslides here in Oregon? Well, we have sort of the perfect trifecta of conditions that lead to landslides. We have steep slopes, we have a lot of weak soil and rock material, and we have a lot of rainfall. And so, spoiler here, climate change isn't going to be helping with our problem anytime in the near future. So with those conditions, that's part of why we have landslide problems. But there's additional factors that we have that people don't normally think about with landslides. Maybe not so much unfavorable geology, geologic structure, nature of materials, lead to a lot of additional problems with landslides. It's sort of a curse to have interesting landslide in that they're usually the result of or the cause of some sort of geohazard, including landslides. And so the other part is, as the highway system ages, the features that help keep it in place start losing their capacity to do so. And drainage is the most important in that aspect. So the more water we keep out of our landslides, the more stable they are. But as you can see in the middle picture, these things degrade over time, and things like highway culverts or inlets have a fairly short lifespan and need to be replaced. And it's not easy to replace them, but when they do fail, they usually bring a larger bit of the highway with them. And then we have sort of pre-existing conditions here in Oregon. We have a lot of very large historic to ancient landslides that have been sitting here for hundreds to thousands of years, just waiting for somebody to come and build a highway across them so that they could move. And a lot of these are also on the coast and have the toe of the slide actively affected by coastal erosion, which sort of accelerates their movement. So we've sort of built our way into a problem that we're predisposed to have anyways. So now we're having to deal with it. So getting into the climate concerns, landslides are extremely climate sensitive features. Rainfall is the biggest trigger of landslides, and it isn't just the total rainfall every year, but it's largely the intensity of rainfall that triggers landslides. So all of the climate drivers that we're expecting will increase the frequency and severity of landslides. So coastal erosion is obviously affected by a lot of the storm issues. So increased storm surge, increased wave height, increased storm intensity and frequency are obvious drivers. Sea level, where we have toe erosion at a certain sea level, then increase in sea level is going to increase the level of coastal erosion. And that's really not beneficial for us. And again, rainfall intensity is the most severe problem with landslides everywhere in the state. And I don't have a great picture to show what rainfall intensity looks like. I don't take pictures of the rain necessarily, but I figured that the rainbow over the drilling operation would tell that story. And of course, extreme heat and the factors that contribute to wildfire are also a problem with respect to landslides, because as we lose the vegetative cover that protects the soil from erosion, also increases our vulnerability to landslides. And we're seeing a lot more problems with wildfire as well. The heat and intensity of the wildfires we've been seeing recently have been very significant. So my photo here is up in the Columbia River Gorge in the area of the Eagle Creek fire that occurred in 2017. And it was more of our normal forest fire that we saw, where we had the understory burnt out, much of the crown, but left a lot of woody material and even some live trees in place. What we're seeing now is moonscape, where the fires come through and they remove all vegetation, and we're left with nothing but bare mineral soil that increases our susceptibility to landslides, and especially debris flows, which are a rapidly moving landslide that come with a significant physical risk as well. So as I mentioned, our unstable slopes system, it started out as a way for us to evaluate risk and help with proactive mitigation measures. And it was originally intended for maintenance and project selection, which it worked well for that. And I'm glad Sarah brought up the issue of focused studies that can lead to decision making. And that's what we in the geosciences sometimes lose track of with some very broad vulnerability and risk studies. But fortunately, I did apply the same principle when we developed this program, and it is specifically designed for project selection and looking at the economic factors and best use of limited funding for landslide and rockfall mitigation. But it isn't necessarily transferable immediately to resilience studies. When we started on this program over 20 years ago, we knew that climate change was going to make this worse for us, but we, as an agency, weren't looking long-term at the time. And we didn't have a climate office back then either. But as it turns out, over the years of collecting a whole bunch of data, we have been able to contribute a large body of work to our resilience studies that have helped us come up with better plans for the future. So sort of a happy accident, if you will. Quick sidebar, we have a kind of an interesting problem here in Oregon. We have a series of land use goals that govern land use and planning here in Oregon, and our goal 18 is a program to protect the coastline, but not necessarily from erosion. Is to protect the coastline from unsightly development. And so what it does is it restricts the use of riprap where it can be applied, and it's only you can only use it if your structure was constructed prior to 1977. And even though the highways were all built long before 1977, they're exempt from this. So we actually cannot protect the highways with riprap legally. And so, there's other solutions. We try to use biostabilization methods wherever we can. It's a great dual use method for preventing erosion specifically. And also, more vegetation cover helps with the overall climate issue. Unfortunately, a lot of our coastline looks just like this, very high, steep slopes with a lot of weak soil and rock that's barren. We can't get anything to grow on it, and it's usually being actively eroded by the ocean. So biostabilization just doesn't provide enough strength to resist that erosion or to support these kinds of slopes. So we're working with our sister agencies and regulators to work on a programmatic approach to strategically apply riprap, because the accelerated erosion that we've seen and the problem that we have necessitate a few bends and flexes for all of us to be able to sustain the transportation system, especially on the coastline. So the sheer number of landslides, the only thing we can do is try to keep up with them. So the main thing for us is routine maintenance, the day-to-day landslide repair. And so when we see movement, we simply just patch over it as we go. And, that's not a great strategy, but it's the strategy that we can afford, and it's the one that we're good at. It's not sustainable. We recognize that. And once things get to where, every year is a disaster for us. Basically, we have a wet season in Oregon, and we have severe landslide movements every year. Normally, our maintenance forces can keep up with those. Occasionally, we have larger storms or series of storms that we need additional funding. Sometimes we get federal aid to do that, and we institute certain emergency repairs. And those funds, federal funds come with some strings that, don't include betterment, which is a catch-22 for us, because the reason that the highway failed in that area is because it wasn't built to withstand what was happening to it. And so putting it back the way it was isn't always the best approach, especially in a designed repair. You don't want to have to revisit the same site more than once in your career. And then when we get to our construction program, the STIP, every state has a state transportation improvement plan. That's where we actually select and design projects. And for landslides, that is our permanent repair. And this is where we build actual resilience. This is where we look at a landslide, look at all of the factors of safety, and design for a select factor of safety so that we hopefully don't have to deal with this ever again. And then, of course, the cost of doing our business. Tracking landslides is a tricky technical task. Watching how they behave over time takes a lot of instrumentation and tracking, and only a select few of our landslides actually have that much attention paid to them. They do show a consistency with expected changes in the climate. But the one thing we do track well is finance. And so looking at trends in our landslide maintenance costs definitely show a trend. Now, looking at this graph, you can see in the last 10 years, we've had a pretty sharp increase in what we're spending to maintain highways from landslide and rockfall damage. And of course, we've seen a spike in inflation recently. And even as bad as that's been, this is much more than just the inflation. We are definitely having to work harder to keep our system in place due to landslide activity. We looked at this business as usual system about 10 years ago in a study that we worked on to look at adaptation options. And this was we did some very conservative analyses to look at what our future problems would be. And even with all of that conservatism built in, we recognized that our methods were not sustainable, and we were going to have to take some different approaches in the future. Even just our routine run-of-the-mill landslides that get patched every year are going to get ahead of our ability to do it, and we're not going to have the funding to continue to maintain what we have. And then our very larger landslides are really going to just put us out of business, and we were going to be looking at some long-term closures in some areas if we don't take some proactive action. So getting to our agency's resilience plans that have been informed by the unstable slope system, we've since come up with vulnerability studies that have advanced us towards resilience planning. So the map here shows sort of the stacks of climate hazards that different parts of the state are going to see. So it isn't just landslides that we have, and our resilience plan isn't just about landslides. Obviously, it is from my perspective, but we have a lot of other issues: inland flooding, very hot weather, and then this is all put on a socioeconomic overlay, because landslides have an interesting effect on a wide range of socioeconomic classes. A lot of the more remote rural areas are disproportionately affected by landslides because they are cut off when large events occur, and they don't have other surface routes out of their communities. The other mode, a lot of the very wealthy people like view houses, and so they are also affected by landslide activity, but they can generally afford the mitigation for it. So our concern is connectivity between the more disadvantaged areas and sustaining those people during the disaster events that also bring landslides. So as part of our resilience program, we can say we're institutionalizing resilience priority. And what does that actually mean? Well, for us, it means changing our standards and practices and policies to incorporate resilience work. So as an instance, upsizing our highway drainage is part of our changes, changing our required factor of safety on landslide repair is another. Our bridge section is looking at the raising coastal bridges to accommodate sea level rise, those kinds of things. We're also doing more work in partnership with our academic partners here in Oregon, at Oregon State University and University of Oregon and the other institutions, to be looking at more at climate effects on landslides. And also we have a seismic resilience program that is also overlaying within all of our other problems with climate. The other part of it is also maximizing our resilience investments. We want to not just work on our most problematic landslides. We want to work on the ones that are in the areas where they're going to benefit the citizens the most and keep them connected during future disaster events. And then just overall, the plan is to further build a more climate resilient infrastructure. So our projects won't just be about increasing capacity or replacing worn out infrastructure, but it's going to have the bent of being more climate resilient going forward for the projected climate drivers that we're expected to see. So thank you for having me. I'm leaving you with one of our favorite landslides. Once you give a landslide a name, you're probably never going to fix it. So the takeaway is don't name your landslides. They'll never go away. Thank you.
It's excellent, Curran. Thank you so much for what I found to be a really fascinating presentation. I especially appreciated how you brought in the socioeconomic overlay. I think you called it. I remember having a conversation with an economist about the likely socioeconomic implications of climate change, and he said, climate change is just going to flood everybody. It's going to be a great leveler. We're all going to be equal and equally miserable, and sea level rise hits everybody, right? And my response to that was, well, yeah, sure, but rich people have helicopters and can afford to fly someplace else that's not flooded. So anyway, marvelous presentation. I'm going to turn next to Chelsea Richer. Chelsea, I've been very much looking forward to hearing about your also future-looking work at Fair and Peers.
Great, thank you. Can you see my screen? Great, okay, thank you. And it sounds like you can hear me as well. Thank you so much for having me. I really am excited to be part of this presentation, and so exciting to hear about some of the work in New York and in Oregon. Yeah, I was sort of inspired to join the world of transportation planning and disaster planning, resilience planning, in part by Hurricane Katrina. So that's definitely top of mind for me this week as well. I'm Chelsea Richer. I am a principal at Fair and Peers. I sit in the Los Angeles office, but my purview at the firm is nationwide, focusing on climate adaptation and resilience, building our practice in response to many of the emerging challenges that you've heard so much about so far today. So I'm going to talk a little bit about first sort of how we think about climate and transportation, the intersection of those two things. And then I'm going to focus on a few different projects that we've had the pleasure of working on and the privilege of working on that really focus on the question of preserving and protecting access to and access from. And then we'll open up to Q&As at the end. I think I'm the last presenter, so that's a nice transition maybe into Q&A for the whole group. So we think about climate and transportation really in four separate ways that I think a lot of the time in climate action plans or sustainability plans for transportation get kind of muddled together. Climate mitigation is really related to the reduction of greenhouse gas emissions from the transportation sector. And I think as many of us on this call today probably are aware, we're pretty far beyond that being the only climate action as sort of the key need for the transportation sector. We also think about sustainability, which is a sort of a broader lens on other kinds of pollutants and other kinds of questions of future future sustainability of people's ability to move around and preserving that mobility of future generations, some of the economic questions that emerged today, some of the sort of human impact questions that emerged. So it brings it into this broader lens of how we make sure we can fulfill the needs of current generations' mobility and transportation without compromising that future mobility and freedom of movement for future generations. Then moving into the climate adaptation and resilience space, which is really where today's set of presenters lives, is all about reducing the effects of climate change on the transportation sector and making sure that the transportation sector is prepared to adapt to the changes that are frankly happening right now and coming down the pipeline in the future. And then this question of resilience also comes up and often gets entangled with the question of climate adaptation. But resilience is, again, this like sort of a broader lens on how our systems can recover from shocks and stressors that are caused by disruptions. And sometimes those disruptions are climate hazard related. Sometimes they are not. Sometimes they are human caused, whether that's a disaster as a result of a climate hazard or whether that's, you know, a fully human caused disruption. And when you break it down to sort of its most granular application or sort of manifestation of resilience, we have sort of micro disruptions every day on our freeway system when we have peak hour congestion that emerges, when we have collisions that emerge that back up traffic on our freeway system for miles and miles. Those are all sort of micro disruptions. So I think the world of climate adaptation is somewhat new for the transportation sector, but we can really apply a lot of our long established thinking in the transportation planning and engineering space to these newer questions of climate adaptation and resilience. Some of the principles of our practice that we like to lead with, I'll just really quickly go through these. And I think because it is somewhat of a new area of work, we found that there's a lot of either confusion or muddling of terminology, some of which I just went over. But we also do a lot of public-facing engagement work as part of our climate action plan work and our resilience work. And so we found that it's really critical to really be clear and succinct with what we're saying and how we're explaining problems and solutions to the public. It also really helps internally for conversations. Not just general public likes to have things clear and explicit, but so does everyone. And so our analysis and processes really aim to retain as much nuance and thoughtfulness as possible, but we continue to synthesize our communications until that message is clear. We also try to avoid the easy trap of climate pessimism. I'm sure, as many of you know, working in this space, looking long term and seeing some of the impacts today, it's really easy to fall into this trap of climate pessimism, especially because so much of it is outside of our individual or jurisdictional control. And so we really try and be solutions oriented towards what is within our control and then collaborative outside of that space, and really emphasizing the need for interjurisdictional coordination and regional solutions and building collaborative spaces to have those conversations. And finally, we really focus on locally specific across the board, whether that's project goals, whether that's the data sources that we're using, and whether that's communication styles. And because we do this work in California, we do this work in Florida, we do this work in the Rockies region, Pacific Northwest, we have a lot of different perspectives on what those local priorities are. And so we really emphasize keeping things local, and we offer lots of choice and guidance on how to do that. Okay, so now to get into the presentation of protecting access. This is sort of the guiding principle of our approach to climate resilience and adaptation work. We've heard so far from our presenters today a lot about the engineering strategies and the incredible investments that have been made in the Port of New York and Jersey and in Oregon across the freeway system there, the highway system there. We hear a lot about the engineering strategies to build resilience into transportation assets and structures. And that is a critical foundational component of doing this work well and building our transportation systems that can be adaptable and resilient to the climate hazards now and in the future. But the lens that we really try to bring in is this lens that transportation assets should be protected, not just for the sake of their continued existence, but for the sake of really serving the underlying reasons of why people travel. And in our work, we try to bring that understanding of how the systems work together, whether those are freeway and highway and bridge systems, whether those are water systems. We're not water specialists, but we do often work across sectors with water specialists because there's a lot of overlap there in how our infrastructure has been built. And really working together to provide a lens on our fully integrated transportation system that continues to provide access to destinations, access to opportunity, and access to the freedom of movement. So we're not just protecting assets, but we're protecting assets or access, excuse me, I think I said that backwards. We're not just protecting assets, we're protecting access and sort of the underlying purpose of why people travel in the first place. And that raises a lot of questions of, you know, I think the question of prioritization and maximizing those returns, which you've heard from some of our speakers already. Okay, so I'm going to go through a couple of project examples of what we mean when we say protecting access to destinations. Just framing this up a little bit, there's sort of two ways in which access to destinations is compromised as a result of the climate hazards that many places around the country are facing. There's this indirect and direct access kind of bifurcation of climate risk here. And so on the direct impact to access side of things, you have a climate risk like flooding, like sea level rise and storm surge combined together, and you have the result of lots of vulnerable transportation assets, whether those are bridges or roadways or tunnels. Those are directly vulnerable to the climate risk and can create a system interruption across the network that renders key destinations inaccessible. And that's sort of the direct pathway between climate risk to inaccessibility. There's also this indirect pathway that we've had the opportunity to work on a few projects where this has kind of come into the forefront of the conversation, where there's a climate risk identified for something outside of the transportation system, whether that's a water system or land that's vulnerable to being flooded. And so there's residences or businesses that need to be tackling how they want to handle their response to the climate risk. But so there's a sort of vulnerable communities unrelated to transportation that emerges as a result of the climate risk. And then there's adaptations that are proposed to address those risks for the community. And maybe there are transportation systems and modes that aren't totally folded into that assessment. And so the adaptations could themselves create a system interruption either through a construction period that is very disruptive to people's access to transit or roadways that then again renders key destinations inaccessible, or things that just sort of kick the problem outside of the jurisdiction that is solving the vulnerability, but kicks it sort of down the coastline. And we see that in coastal erosion issues a lot, where coastal hardening efforts may relocate the erosion issue, and it's no longer part of their jurisdiction, but it is still a climate risk and a problem to the transportation network. So I'm going to talk through two sort of concepts in action where we have a couple of projects where we've worked on analysis that helps to illustrate and illuminate these things. And I'll drop some links in the chat. There's a recent ITE journal article published on this Volusia County vulnerability assessment, which is in that category of direct impacts to access. So the project goals for this one was to identify the barriers to people's ability to access destinations outside of Volusia County and destinations within Volusia County during flood events. And I'll just go back one slide so you can see sort of where we are in the world. This is in Florida, on the eastern coast of Florida, and you can see that Daytona Beach is maybe the most well-known community outside of Florida that is within Volusia County. So that's where we are. You can see in the map of Florida here. So lots of flooding risks that are made more extreme. Obviously, hurricanes have been around for a long time, but made more extreme by sea level rise and this increasing intensity of storms and rainfall. So the goals, again, were to identify barriers to access within and outside during a flood condition, not necessarily during an active hurricane, but in the days maybe that follow when roadways are still flooded. So our analysis looked at NOAA hazard scenarios. We also pulled in local critical assets as they were defined. And when we say assets here, actually, we're not talking about transportation assets. The broader vulnerability assessment that Volusia County was doing talked about critical assets defined really as hospitals and community centers and public works department locations in the field. So things that were sort of critical to maintaining continuity of business across the county, whether that was people's access to places or whether that was the county's ability to get things back in order after a flood. We also use local census data, and we have developed a tool. So our approach is really following this use of some of the tools, and maybe we're getting down into the weeds here. The Resilience Plus tool that we've developed leverages some GIS network analyst capabilities to investigate distances and rerouting as a result of hazards. And I'll just go to the next slide where we can show some of the results of this work. Moving from left to right, we have the 3 scenarios that we investigated. That's from least to most sort of extent of flooding, as you can see. 2040 category 1 storm, 2040 category 3 storm, and 2070 category 5 storm. These scenarios were selected obviously in collaboration and direction from the client at Volusia County. And so what you're seeing here on the map is the yellow lines showing the changes in access patterns across the county. The red dots are showing the lack of access that is resulting from the flood. And so you can see, maybe you can see my cursor as I navigate over here. The white dots are showing emergency services facilities. And we looked at, I think, probably a half dozen categories of quote unquote critical assets, which again, those are the key destinations in this project example. So in this set of maps, we're showing the emergency services facilities, and you can see how the communities, which are being visualized here as the centroid of their census tract, can travel to access those emergency facilities. Except along the coast where there's direct flooding, there are 3 facilities that become completely inaccessible due to the flood. And all of those census tracts are now being rerouted out to other locations that are nearby. And so the destination of the routing, or the length of the routing to those key destinations is getting longer and longer. And that's sort of the overall pattern between these 3 scenarios. And that's a problem because the length of travel that people have to do to get to a key destination, like an emergency services facility, if you have a vehicle, that might not be a huge difference between 1 mile and 4 miles. But if you don't have a vehicle or you're dependent on transit, those changes in route distance can be really the whole difference between being able to access what you need to and not being able to access what you need to. So it's a very brief summary. The key takeaways from this work really was that it was the first pass at identifying vulnerable populations as well as the assets that those populations need to access. So it showed the critical assets at risk of flooding as well as the communities at risk of losing access to those destinations. And it surfaced some of these sort of barriers to access that are broader at a community and countywide scale. The key findings include a growing number of hazard areas leading to increased number of people with impacted access. As hazard scenarios are worsening, those average distances to destination classes become longer and longer until finally it's completely inaccessible. And the other key finding that we had incorporated here, or the data that we incorporated here, and that's symbolized with the darker dot, is the average median household income for each of the census tracts. So you can see actually that there's quite a lot of lower income communities along the coast and in this area over here, inland a bit. And so what we were able to identify was actually the average household income associated with the tracts that are also experiencing the most diminishing access conditions during a flood. So starting to correspond that question of community need and priority to access. Second example that I'll walk through briefly is this climate adaptation impact assessment project. None of this is public, so unfortunately I've had to somewhat anonymize the details of this project, but I think it's a great example of this indirect impact to access question. So we had 7 strategies that were identified as climate resilience strategies, climate adaptation strategies that were solving for a completely different problem than the transportation or a problem that was much broader than just the transportation question of maintaining access in this community. And you can see that it incorporates both, it incorporates sea level rise considerations. And so it's really looking at how to maintain access, how to maintain sort of access and continuity for the whole community, not just the transportation network. And so what we helped to do was really articulate these evaluation criteria and metrics specifically for transportation to basically evaluate each of those 7 scenarios for how much facility capacity is changing, how much drive time is changing, how much transit degradation is changing, changes in VMT, which correspond to greenhouse gas emissions and other pollutants, as well as road safety, congestion, so near capacity or at full capacity roadways, on auto mode share. And then we also evaluated this at a citywide lens, as well as within specific environmental justice zones that were identified by the city. And we looked at the geographic distribution to understand whether there were different geographic patterns around the city as well. And so this was basically taking the scenarios that were handed to us and providing this much deeper dive into the transportation impacts. And then as a result, we were able to identify companion projects to those primary adaptation strategies, which would address those transportation metrics and strengthen the outcomes. And so for strategy E, F, and G, which were the 3 that were really being very seriously considered to move forward, we were able to identify key projects that would help address those degrading metrics, and then fold in those capital and operating costs into the overall cost benefit assessment, which helped us provide a much more comprehensive understanding of the costs and the benefits of adapting in each of these 3 ways. Okay, now finally, I'm going to go through what we mean when we say protecting access from. So this is really all about our evacuation practice, and this is really protecting access away from hazards that might be requiring a community to evacuate. So this practice area has been really aggressively growing in the California market because the California courts have been extremely active in legislating on this topic and providing case law, and there's been a lot of litigation related to new projects. So what matters to the California courts really focuses on, it's changed quite a bit in the last 5 or 7 years. And so they've really emphasized this expectation for a rigorous and dynamic approach to evacuation planning. At the project scale and at the plan scale. And so they've emphasized it's important to evaluate how new developments affect evacuation times for the development residents or visitors themselves, as well as for the rest of the surrounding community. And they've also talked about the importance of accounting for traffic control during emergencies, so needing to have tools that are a little bit more refined to understand the difference between a signalized intersection and a stop controlled intersection. They've emphasized the importance of incorporating wildfire expert opinions when planning, and a lot of the time traffic engineering and transportation planning sort of brings the results to emergency responders and asks them to comment on it at the end. But this really emphasizes the need to have that wildfire expert opinion. A lot of those people are first responders right at the beginning of the project as part of the technical advisory committee, sort of weighing in on which scenarios you're evaluating and what the operational impacts or likelihood of the operations of an evacuation might look like. And then finally, creating backup plans that based on the dynamics of the emergency. So this really underscores the need to pull those results of any analysis and planning effort that you undertake into the project description or into the planning approach for emergency operations plans at the project scale or at a plan scale, community scale. So we have that plan/community scale approach that we look at sort of everything within a community and how they might all get around during an evacuation and exit through sort of screen lines is a transportation engineering term for, the point at which someone is safe beyond the area of risk. And then at the project scale, when it is related to a new development, either way, you're sort of working through the definition of each of these points. You're defining hazard characteristics for a scenario. You're really articulating and defining the transportation networks that are going to help people evacuate, whether that's the roadway network primarily, but in some cases also transit networks or transit systems can be sort of deployed as assistant evacuation tools. And then pedestrian and bicycle networks, believe it or not, I think in a lot of very dense urban communities, what we've seen in Los Angeles, unfortunately, very recently is that people do end up evacuating on foot sometimes. So that's something we need to take into consideration as well. We look at the population characteristics, how many people are anticipated to evacuate, how many vehicles will those people leave with, are there populations that need specific and extra attention? Those are called access and functional needs populations in the world of emergency management. And those are folks who can't self-evacuate, whether that's due to age, disability, linguistic isolation, and they don't get or respond to the communications that are being pushed out to the population. Whether those are people who have pets or large animals on their property, like horses, takes different amount of time to evacuate, and those are different size vehicles, so it has a different burden on the network. And then we define key metrics and sort of what are we evaluating for, and who do we apply that evaluation metric to. And then finally, what do you do about it? So if you've established a really great planning and analysis methodology, and then your analysis results in lots of congestion or lots of access impairments during an evacuation, what's the best approach to incorporating that back into capital improvement plans or operations plans to really address what might be a constraining factor during evacuation? So this project that we worked on a few years ago at this point helped really establish this dynamic traffic assignment methodology for evacuation planning. And you can see on the right-hand side here, this allows a much more granular sort of slicing of the congestion environment during an evacuation, really during any event, but overlaying the evacuation scenario on top of it. So it's coinciding with the heaviest traffic period in this region. This is in Southern California, east of Los Angeles County, and just in the foothills of the San Bernardino Mountains. So in a wildfire risk zone, but also these thicker lines on this map are the regional freeway network that are likely going to be carrying large volumes of people, just through the region that might not be related to an evacuation event. And so this really looks at how the congestion conditions worsen or sort of evolve during an evacuation that coincides with that peak period morning rush hour. And you can see how with every 15-minute time slice where the congestion picks up and how it moves through the network. And this allowed us to really identify opportunities for improvement or even operational changes, like maybe the freeway gets closed during an evacuation event for anyone traveling through so that you can preserve some capacity for people traveling out. So this was a great example of a very deep dive. I'll drop a link to the full analysis of this project so you can see for yourself how deep we get into the traffic and travel demand modeling space. And then the question of what we do about it, how we improve evacuation outcomes. We currently have some research underway that is part of our discipline group work. Our discipline groups are sort of our self-funded research and development arm at Fair and Peers. And so we have some case study research underway to identify qualitatively through literature and AAR's after action reports what differs from evacuation to evacuation, what people describe as evacuation success, and what kinds of mitigations or changes were made to sort of result in that success. We also are working through iterative modeling to understand what kinds of changes you could make to the transportation network that might address some of those congestion issues that emerge. And then finally, we're also looking at better data, real-time data, and there are a lot of vendors out there that use connected vehicle or connected device data to inform congestion patterns. And so we're looking at basically exploring Streetlight Replica, Azira, INRIX, TomTom data to understand what can be sort of pulled and disaggregated at the scale of just a couple of days during an event, and understanding a little bit more about what happened during an evacuation, not just what people think back and report on during an after action report. And with that, I think my time is up.
Thank you so much, Chelsea. It was a fascinating presentation. Really, really interesting approach to these problems. I would like to invite all the panelists to turn your video back on, and I've developed a couple of questions from the very active conversations that have been going on in the Q&A. And first, let me thank the panelists for having responded to many of those questions on the fly fly as we've been going on. It's very, very impressive, particularly Sarah and Angela, the amount of information you guys were able to whip out just like that in response to questions. It's really great to see. There are some broader questions in the Q&A that I think you all may have thoughts on, and so I want to invite anyone who has a view on this to weigh in. And I think there are at least a few different themes that are coming up. One is a theme of trade-offs. How do you go about thinking about the calculation of savings from different resilience investments, and what cutoff do you use in terms of a 100-year hazard versus a 500-year hazard versus a 1,000-year hazard? All of those hazards would imply drawing a line at trade-offs at different points. So trade-offs is one kind of theme. Another theme is the theme of technology. How should we approach the possibility that there are new problems of for instance, autonomous vehicles in disaster situations and in natural hazard situations. And I think there was also an interesting question raised about different transportation modes, as technologies, and how do we factor that into our thinking. Curran, you raised that issue too about how the slopes and unstable slopes and landslides can impact any form of transportation, right? From rail to automobiles. It's not just highways, right? And then something that came up too in the different presentations was the question of technique in engaging people who are elements of these transportation systems, and whose access are things that are trying to be protected here. And so that's like way too much probably for us to take on. But I just wanted to acknowledge the great questions that were asked by Alexis Subro, Trevor Rourke, Ellen Partridge, Colin Clark. These are great points that are being raised. But I wanted to invite you to dive into the technology question specifically. The autonomous vehicles seem to be coming pretty quickly to lots of different places, and so I'm wondering how that is shaping your thinking about planning for natural hazards of the water and heat and other sorts.
I'm over here looking at my peers who have a lot more roadway access than they seem to be looking at. We've piloted some autonomous vehicle programs, or we're kind of in the process of doing so at our airports, and I haven't really thought much about the challenges of autonomous vehicles navigating areas that don't look like they had been previously mapped to, or relying on their systems to be able to tell that certain areas are impassable or something like that. But I think that we are facing some of these issues with EV vehicles, and looking at trying to balance the need to decarbonize and electrify, while also making sure that we have redundancy and diversity of means of getting around. You don't want to put all your eggs in one basket. And also acknowledging that we need a lot more capacity. So looking at expanding our capacity and building it quickly, but building it and making sure that we're investing in building it high up in areas that that won't flood from stormwater or coastal surge, looking at keeping them cool efficiently. So making sure that whichever way society sort of decides to lean EV and autonomous and so things I haven't even thought of yet, that they can be fueled in ways that are as resilient as possible.
On the evacuation side, there may also be some opportunity for driverless transit vehicles to help facilitate evacuation. during hazards where, you know, operators of transit vehicles are also evacuating. I think that's a current limitation on use of transit systems to help evacuate a community when it's putting people into harm's way as part of their job. But there might be some opportunity there. I haven't seen much in the way of that idea yet, but it could have promise.
For us, it's an issue we're aware of, but it's Oregon still being a very rural state. Most of it probably won't have a lot of autonomous vehicles. Most of what we're looking at is in the more urban areas, Portland and Eugene, where we do have actual landslide problems. But we would be looking to the provider of the autonomous vehicle to synchronize with our own dispatch system so that we would, you know, lock them out of areas where we know we're having problems, so they simply wouldn't drive into a hole where there used to be a road, or so, you know, working with the technology to control it for now. But we also are, you know, concerned about evacuation plans, especially seismic lifeline issues on our coastline where we have a tsunami problem. So we are also looking at those sorts of evacuation planning, and the autonomous vehicles would be very helpful, especially, you know, the vulnerable populations that aren't as able to evacuate.
Oh, super interesting. Thank you, everybody, for weighing in on that. Yeah, I'm conscious of the time, so I should bring us to a close here. I certainly want to thank everyone, all the panelists, for some really great presentations, as I imagined they would be. You're all just wonderful, and I'm going to share my screen just quickly because I want to point out a couple of resources. The first thing that I just want to remind everybody of is that the next webinar will be October 29th to make room for Harvard Climate Action Week coming up in September. And this webinar, along with the previous webinars in the series, are all posted online. If you use the QR code down at the right-hand side under where it says webinars, under the where it says files, that QR code links to the previous webinars from 2024 that the DOT Climate Change Center did, as well as a huge array of very helpful US DOT resources, some of which are still available online, others of which are not. But this is our archive of things. So with that, I am going to close us out and invite the panelists to join me on the optional debriefing link if you're able to. And for the participants who are able to join us today for the webinar, thank you all for joining us and being part of this community. Look forward to seeing you again in October. Be well.